So this is scene 3, the proton transfer scene. If you click play and click OK, you get the 1, 2, 3 choices. So 1 and 3 I have animated, which you can try, but 2 doesn't do anything. So you get an error message if you click 2. So this is what I'm asking you to build the animation for what happens if you remove this proton right here. So this is going to be a fairly complicated animation. So to do this, click stop. So you're back to the original scene. Then hide the tetrahedral intermediate 1 and 3 done. That's mine. And activate this one at the bottom, workshop tetrahedral int. That's yours. Bring into the scene a prefab. In the prefabs folder, Fischer Essentials, reactant molecules, and scroll down and you should see this proton grabber, crab. So it looks kind of like a crab. Bring it into the scene. And there it is. It's in the wrong place. So set the position to be x equals 5, y equals 0, z equals -1. And it's facing the wrong direction, so change its rotation, z to -90. Now it's facing the right direction. It has a child of this proton, which should be hidden in the beginning. Let's go ahead and expand the proton grabber crab, and you see a hydrogen ion. Simply highlight that and deselect it. So now it's ready to go. Need an empty game object, so game object, create empty. And we'll call this deprotonation animation 2. Okay, because it's the second proton in the 3 choices. So have that highlighted. Position 0, 0, 0. That's important. Then you're going to make these 2 children of the deprotonation animation. So take the workshop tetrahedral int, drag it on top, and it'll become a child. Do the same with the proton grabber. And now you should have 2 children here. In the rest of this video, the top child is going to have a different name in the video than it does for you. It's a tetrahedral intermediate. Ignore the difference in the name. So we should unpack these prefabs as we've done before. So highlight, right-click, prefab, unpack, proton grabber, right-click, prefab, unpack. So the chemical steps, this crab is going to act as a base, so we have to move it to grab this hydrogen here. That proton comes off. There'll be a transient formal negative, collapses to form a double bond, methanol kicked out as a leaving group, rearrangement to sp2, trigonal planar geometry. That's what you're animating. So now highlight the parent, the deprotonation animation, click the animation tab on the bottom, and create an animator and animation clip. Save this in assets, animations, and give it an appropriate name, such as deprotonation 2. And save. So we have a number of things to animate. Going to start with the crab. Expand that. and set the timeline to 50 frames. Click record, and we'll go ahead and move it and have the pinchers close. So to move it, this is a little bit of guess and check. So let's try X 3.3, looks reasonable. Y looks like it needs to go up a little bit. So how about 0.7, a little too high, 0.66, 65, looks good, okay? Then the pinchers here, which are children of the actual crab game object. Right pincher, Z equals 10 as the rotation. So if you change that to 60, you'll see the right pincher arm comes down, ready to grab that. Similarly, left pincher starts at -10, move it to -60. All right, so I'm going to look at that. Approaches, boom, beautiful. Okay, so this is where we'll now create an illusion. Timeline markers at 50 frames. Record button is on. At this moment, the hydrogen ion will appear. So highlight the hydrogen ion and activate it with this box in the upper right. And you can't see it because it's hidden by the existing hydrogen, but that hydrogen should disappear at 50 frames. Before we get to the changes that occur in the tetrahedral intermediate, let's have the crab retreat with its proton. So go on out to 100 frames. Zip, 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 100 frames. Okay, so now at 100 frames, we can just have this proton grabber retreat. Reasonable. Okay, so I just changed the x coordinate to 6. And if you look at that, it looks like it's pulling away the proton. Now we're going to close up the proton grabber crab and open up the tetrahedral intermediate protonated. This is not the best labeling, but the oxygen where the changes are going to occur is this double bond to oxygen. Because it was originally a double bond, it's going to turn back into a double bond. If you need to expand further, expand further. The oxygen here is this oxygen atom. There is a hydrogen atom attached to it. So set the timeline marker to 50. Highlight hydrogen atom 1, simply make it disappear at 50 frames. Click this box in the upper right, it disappears. The bond stick is right here in the hierarchy. It should still exist up to 50 frames, but then it should shrink away. So with the timeline on 50, I'm going up to the transform position and just retyping what's already there. So 0.75 is what's already there. And what that does is it creates a keyframe is what it's called, saying at 50 frames, no change has occurred in this bond. But over the next, let's say 25 frames, this bond will shrink back into the oxygen. To do that, timeline's at 75. Set the Y position to be 0. Set the Y scale of that bond to be 0.2. And now let's take a look at the illusion. So starting from the beginning, the crab approaches. Looks like it's grabbing that, pop, and pulls away. Timeline set to 50. Find this formal negative marker, the child of the double bond to oxygen. It is inactive from the beginning, but at 50 frames, when the proton comes off, it should become active. Then we're going to make the double bond appear. And to do that, see, double bond oxygen has 2 bond sticks as children. So one of them is currently visible, and the second one is not. So at 50 frames, set this bond stick 1 active. You can probably barely see that it's a double bond. And we don't want it to suddenly appear. It's going to gradually appear as the bond to hydrogen disappears, the double bond to carbon appears. So highlight bond stick 1 at 50 frames. Set the Y position to be 1.5. Set the Y scale to 0.2. It's hidden inside the oxygen. And now drag the timeline out to 100. Bond stick 1 will now be Y position 0.75. Y scale 0.5. Okay, so you may be able to see it now. From 50 to 100 frames, there's a second bond forming right there. But doesn't look great as a double bond. So what we have to do is now timeline marker at 50, highlight bond stick, which is the current single bond here. Go ahead and record its position just by typing over what it already is. So type over 0.75 and it creates a keyframe, so it's recorded the position. Drag this out to 100 frames. And I believe it will look good if you just make this X coordinate 0.1. So you see how it looks much better as a double bond. Crab grabs the proton. Formal negative is there, but then formal negative should go away. Double bond forms. Okay, once the double bond forms, the formal negative should go away. And the methanol will have to leave. So all that's concerted. Formal negative marker, highlight that. We've got an animation that just makes it appear. So set the timeline marker to 50. Look at the scale and just type what's already there, 0.108. Then bring the timeline marker to maybe 85. This is personal preference. Make the X scale be 0. We'll make Y scale 0 also, it doesn't really matter. Okay, so now the formal negative is there transiently, but it fades away. I think drag this out to 100. Otherwise, students will miss the formal negative. So you can do this. We've already got the desired effect, but it's in the wrong timeline position. So click the top diamond, drag it out to 100, and now the formal negative will shrink over 50 frames. Beautiful. Two things left to do. Methanol has to leave, and the bonds on the carbon need to adopt the sp2 geometry. So I'll do the bonds first. Set the timeline marker to 50. Highlight double bond to oxygen. Record its current angle by just typing over. Z is 70.5 degrees. Type over that. And then at 100 frames, make the Z angle be 90. Similarly, bond to hydrogen. bond to OH group. You can do them together since they are going to do the same thing in terms of angle. Timeline on 50. Just type over what's already there, 70.5. And then at 100 frames, record their position at 90. So you can now see that's a trigonal planar geometry. We just got to get the methanol to leave. Timeline marker at 50. Maybe close up the carbon sp3. Boom. Expand the methanol. Record its current position by typing over what's already there. Negative 1.5. Then, so bring the timeline marker up to 100. Make the Y position of the methanol drop down. So Y position negative 2.5 is probably reasonable. Hoping you see, we need to get rid of this bond that's on top. We need to get rid of the formal positive on the same time scale. So why don't we do the formal positive first? Highlight that. It is a child of the methanol. Timeline on 50. Formal positive marker. Retype what's already there. 0.108. Timeline on 100. And the formal positive is 0. Doing both X and Y, but 1 is sufficient. Okay, so the formal positive shrinks away. And now highlight the bond rotatable straight up. That needs also to shrink away. Timeline on 50. Hit backspace on this scale and retype a 1. Okay, so that creates a keyframe at 50. At 100 frames, that bond will shrink in scale. So Y scale 0.2, and it's inside the oxygen atom. Go ahead and scroll through the animation to see what it looks like. All right, so I am going to add one more thing to the animation. I think it should continue to drift away. So if we go out to 150 frames. Methanol. Position, Y position, -5. We'll bring it down. And I think it will look nice if this methanol rotates as it's drifting away. So timeline marker on 100. Record the rotation as maybe -1. -1 degree on the Z, and then after 150 frames, it can be -45. Okay, so then on your animation window, click play, and you should see it repeatedly go through these motions. All right, so click unplay, click unrecord. We're ready to go. Highlight the animated complex, go to animator. Should be this orange box. That's all the animation you've done. If you click it once, there's a box for speed in the upper right. Recommend something pretty slow like 0.2. Double click it and take off the loop. Should be able to see it now when you press play in the game window. Crab comes in nice and slow, grabs that proton, pulls it away, formal negative. Beautiful. Now you should save the animated complex project folder, prefabs, Fischer Essentials, transition states and drag your animated complex so it can be a prefab. Now you just need to link your transition state to the original game object. So highlight your deprotonation animation and deselect it. Go back to the original tetrahedral intermediate, 1 and 3 done. Select that. Expand that game object. Expand the sp3 carbon, and you should see pointer arrow 1, 2, 3. 2 is the one you need to link. So highlight that. On the right, scroll down until you see this pointer arrow script. Animated TS for this choice. And this is where you take your newly made deprotonation animation 2. Drag it into that box. And it now should work. So hit play. Click OK. And click button 2. And there it goes.